Hey guys, this side Narayan and I welcome all the viewers in this video in my YouTube channel as well. So guys, I'm just going through with the topic of CompTIA A plus certification volume 1 lesson 1 and this system board form factor now in this video because it is always good to understand topic wise all the things, because in one video you cannot understand, you will messed up with lots of things. So it is always, this is my personal experience of learning something. So if you go topic by topic, then it is very good and it gives you clear clarity and understanding. So that is what I'm just trying. So in this video guys, we'll understand about all the form factors what we have system board. And if you find this video helpful, please don't forget to subscribe my channel, comment on this video, share this video and like this video. So, and if you want to find it, it is available on my Facebook page also. So I have one CCNA page here. Okay, this is my Facebook page, and if you go here and post, then you will get all the videos whatever I upload on YouTube, so you can find from there also. So guys, let me begin with this video in this. So as I told you, this topic is all about system form factors. So what we have, we will understand in this. So the form factor describes what is form factor. Basically, you should be knowing what do you mean by form factor. So basically, they describe the size and shape of the system board. That is known as system form factor. Okay, very clear, very easy to understand, very easy to remember. They will define, they will describe the shape and size of system board. That is known as system board form factor. So we have couple of form factors. So very first one is full size AT. Okay, so this is a structure of this full size AT system board or motherboard. So if you see here, memory slot we have this side, CPU slot we have, chipset we have, AGP slot, memory slots, and ISA slots. This is your front view and this is your rear view, and keyboard connector here, and power supply is here. So this is what if we talk about full size AT form factor system board. And if we understand, so this is what if we talk about, we are full size AT. So if we talk about the later one, so there will be certain changes on the board, like this will be somewhere here or like that. So that is what the difference between all the um, system board. So we will understand one by one. So if we talk about this one, so very first one, this form factor is usually used in older system. Okay, older tower system. So when these tower systems came, they were having this full size AT system board, because it was developed earlier. So whatever is old, they will be little bit different as compared to the today's what we have. The next one, originally it was designed from an even older system. The original original XT motherboard, which itself was designed for use in the second version of the IBM PC released in 1983. And the original full size system took up a large amount of desktop space because it is quite big in size. A vertically oriented tower system using the 80-volt can stand on the floor and not take up desktop space, and they can still use the full size system board. So these are the characteristics of this full size AT system board. Let me move to the next one. And if we talk about little bit more this, so this system board was like 12 inches by 13.8 inches, 12 to 13.8. Okay, a transfer bus of 16 bit or better is required. It uses CMOS to retain configuration settings, and it has 5-pin DIN keyboard connectors. This one. Now second form factor, which is baby AT. We spoke about full size AT. Now this is baby AT. So we will understand in this. See, this is your rear front. Okay, I mean rear side, and this one is your front side. So if you go back here, couple of things, this we will see where CPU is coming, where memory slot is coming in this one. So if we go back, so CPU is coming here. Okay, this is CPU now in full size AT. But if we go to baby, it came here. And if we talk about memory slot, So memory slot is here. Now in this memory slot, move to this one. So this is how thing or the placement of the device connections and slots keep changing as soon or with the form factor come in market one by one. And there will be couple of changes in this. If we see here, this form factor is usually used in older desktop. So this is also, you can say, old only, not latest one. And in an effort to free up disk space, okay, to, as I told you in this one, it was consuming entire place, or it was very big. So to avoid that, what happened, what they did in this one, they did couple of changes. Manufacturer wanted to build computer that was smaller than systems with full size 80. So they wanted to develop motherboard which is small in size as compared to full size 80. So they thought couple of changes to bring in this version of form factor. The popular 80 motherboard was scaled it down to create the baby 80 motherboard. So they did couple of changes and manufactured this one, and it fits into a smaller case than the full size 80 board, but it is otherwise the same. It works in any case except for those considered low profile or slimline. This was an extremely popular design because it was came later on uh, after this version, and it was not I mean, as a size it was very big, but it was small, to it was quite very popular in market. And this board is usually 13-inch by 8.5 to 9 inches. It was never developed as a standard, so there are variation on the size of this particular board. So there could be different in size also. Now next one is system board, which is ATX. Okay, so ATX, now this is your rear one, okay, back side, and this is your front one. So let me go back. This is rear one and this is front. So what is different, this baby 80 and now this ATX. So CPU is here, and IO input output connector here, and let me show you CPU where is in baby ATX. So baby ATX, baby 80, CPU is here, and keyboard mouse, I mean this in IO connectors here, and there will be couple of changes. Now RAM came to this place, and here RAM was here. So this is little bit different as compared to baby 80. We will understand here. Compared to 80 system boards, the ATX form factor board provide better input output support, okay, lower cost, easier use, and better processor support. Some of the feature of the ATX board we will understand here. First of all, power supply with single key 20 pins connector. So we will have, as you can see, this is much better as compared to the rest of two, full size 80 and baby 80. So here we have single power supply, okay, key 20 pin connectors. So it will be having 20 pin connectors rather than requiring voltage regulator VRM to reduce voltage down from 5 volt to 3 volt, or 3 volt DC is available directly from the power supply. So that is the main concept. My in my previous video I have uploaded, I mean I have spoken about what is power supply and what does it mean, this changing voltage. So basically we used to, I mean, why we use power supply in system, to just convert AC to DC, okay, and DC will be required for system, not AC. So this is the main function of power supply here, and we do not need manually convert those AC to DC or 5 volt to 3 volt. So directly it will, I mean, this will supply as per the requirement of the computer if we have proper power supply in ATX board we are talking about. The CPU is closer to the cooling fan of the power supply. So CPU, this one, okay, and somewhere I have not taken where the power supply is. Power supply should come somewhere like this, so it is nearby this only, okay. And memory as well, it is nearby memory. And next thing, input output ports are integrated into board along with PS2 connectors instead of 5 pin connectors, and you can access the entire motherboard without reaching around drives. So if we want to remove it, we can remove it easily. and this was accomplished by the rotating the board 90 degrees. The board cannot be used in baby AT and LPX cases. The board is 12 inch by 9.6 inches, so these are the differences, and this is much better as compared to the rest of two. Next form factor is micro ATX. Okay, we spoke about full size AT, then baby AT, then ATX, now micro ATX. So what are the changes in this board? Once again, so keyboard is here, okay, and this is your 9.625 inches. This is what the length, and this is front view, and CPU moved to this place. Earlier it was coming somewhere here in ATX, and this is micro ATX, and this is AGP slot, PCI slots, ISS slot, and chipset. So we will understand couple of things here. With a maximum size of 9.6 inches to 9.6 inches, which is 244 mm by 244 mm, micro ATX boards with integrated graphic are often used by system board manufacturer as a basis for small form factor and home entertainment PCs. And micro ATX board can often use the same component as ATX board, and there are fewer IO ports available than ATX system, so it might be necessary to use USB hard drive or expansion cards, CD burner, and so on forth. So this is the difference between ATX and micro ATX. And the next one is LPX system board form factor. So what is the difference in this one? So if we talk about this one, I think I have missed the image or what. This is not the actual image. Let me tell you about this only. It's theoretical part. So guys, in this slimline and low profile cases, which are today's typical desktop cases, were being developed about the same time as the baby ATX motherboard was introduced. And however, these smaller cases could not use even baby ATX board. The LPX and mini LPX board were developed for these cases. Okay, and I mean, they provided riser card functionality. A riser card is used to plug expansion cards into the motherboard. This is the only, and this riser card available enables the expansion card to uh, lie sideways like this. Here these are the expansion in the same orientation as the system board, and thus the case does not have to be as high as the card. Okay, and another difference in this board is that it uses PS2 style keyboard connector rather than 5-pin connector used on the AT boards. Video parallel and two serial ports were placed at the rear side of this board, and this board is 9 inches by 11 to 13 inches. A mini LPX board was also designed, which was 8 to 9 by 10 to 11 inches. So this is the board I was talking about. This is LPX only, there is no difference in this. Okay, so guys, and if we talk about now NLX form factor. Okay, so in this you can see size is totally different, or I mean, this each and everything is completely different. Okay, shape itself is different in this one. So the NLX system board replaces the LPX system board. It is a smaller form factor designed around the Pentium second processor, and it supports advanced in memory and graphic technology such as DIMMS or AGP, and it is used in newer slimline design systems, and the board size is 8 to 9 inches by 10 to 13.6 inches. And here again they have changed couple of things. This is AGP port, and if we go back, where is AGP port? Here, not in this. In this, AGP port is here. So this is how they have changed the places of all the uh, component on different form factor of the system board. And memory came to this place, CPU came to this place, PCI ISS ports, peripheral ports. So these are the, you can say, the basic difference between all the form factors. And if we talk about the next one, BTX form factor. So again here, as you can see here, this is front view and this is rear view. So PCIe came in this one. At this PCIe slot is, I mean, improved slot, you can say, or enhanced version of the PCI. and here PCI slots all as well, keyboard, memory slots, chipset. Let me read little bit more things here. So they include low profile. The back plane is in inches lower than the ATX. Okay, and the next one is thermal designs. The BTX layout establishes a straighter path of airflow with fewer obstacles, resulting in better overall cooling capabilities. Structural design, the emerging need to for heat sinks, capacitors, and other component dealing with electrical and thermal regulation has resulted in device that can physically strain some motherboards. So these are the improvement, if you say, as compared to the rest of in this BTX board. And the BTX standard addresses the issue of specifying better location for hardware mounting point. For example, the chip that makes up the system's chipsets are located closely to each other and to the hardware they control to reduce delay in data transfers. Okay, so RAM is connected to this chipset only, nearby this only, and CPU is also, so that the communication should have faster. They made that kind of changes. So guys, in this video this much only. Thanks for watching for this video, and if you find it is helpful, please don't forget to comment on this video, share this video, like this video, and subscribe my YouTube channel. And in my next video I will be talking about what are the storage devices and what does it mean, what we have in storage devices, one by one. So if you subscribe the channel, you will be getting the notification of the upcoming videos. So till then, bye bye.